And welcome everybody to this spring symposium of the Royal Society of Chemistry Education and Research Group. I'm Michael Seary, a member of the SERG committee, and plenty of SERG committee members in the room today, including our chair, Catherine Haxton. And this is a very special symposium for us. We always like to try and celebrate those among our community. So today we are celebrating Dr. Audrey Cameron. And my main task really in this opening gambit is to introduce Helen Payne. So very happy that Dr. Helen Payne, who is Chief Executive of the Royal Society of Chemistry, is joining us today. Many among us know Helen, and when she was appointed in the tough days and months of 2020, Helen spoke about the role of chemistry and society and its importance of having a positive impact on the world. And I think those of us who are long associated with the society can be in no doubt that Helen means what she says in that regard. She's navigated the society and the chemistry community at large to address many of the major societal consequences and considerations of our time. She's continued, and I would say substantially expanded, the society's reach and leadership in a broad range of areas centered on chemistry's role in the world. And a major component of this has been on the focus of the diversity of people that make up the community of chemistry that the society represents. She's led society to be a leader and a proactive voice on a range of issues relating to inclusion, diversity, and accessibility. And I would recommend that anybody interested in that work explore the Society's web pages. So with all that in mind, I'm really delighted and honoured that Helen is available to open the symposium and introduce you to our first speaker, Dr. Audrey Cameron. So Helen, over to you.
Michael, thank you so much for your very kind introduction. It's been fantastic actually to be able to join you. I feel very privileged and very proud, both as CEO of the Royal Society of Chemistry, but also very much part of the community, which I have been a member of for a very long time now. So I've had the opportunity to work alongside our members, but also some really important and influential and inspirational people within the community. And Audrey is absolutely no exception to that. And it's wonderful to see you, Audrey, online. And I'm looking forward to hearing your presentation as well. But we're here very much to celebrate Audrey Cameron, who's had a remarkable story, full of professional achievements towards making the chemistry community more inclusive. So profoundly deaf since birth through incredible hard work and tenacity, Audrey has broken through the barriers to gain a chemistry degree at Paisley University. And at that point, a subject which at that time was not accessible to deaf people, and something that Audrey has worked very hard and succeeded in changing. This was followed by Audrey's doctorate at the University of Strathclyde, and she became the first deaf person in Scotland to gain a PhD. And I feel very proud of the fact that when I think back to 1996, and I think it was at a pre-doctoral symposium in Brunel University, I first met Audrey when she came to give a presentation at that symposium, and that had a really influential impact on me in terms of how the Royal Society of Chemistry helps support our community. And Audrey, thank you so much for showing the way all those very many years ago, and to follow up with all that you have done since. And since Audrey has dedicated her life to working to support fellow deaf chemists, and there are very many examples, including her management of the Scottish Sensory Centre and her work on the BSL Science Glossary. And this has had a significant impact on the deaf community, and this has been truly phenomenal, which has included the development and evaluation of 1,500 new scientific and mathematical signs and production of definitions in BSL for deaf students and their teachers, and also her work on new signs for chemistry, coordinating a team of chemists, linguists, and sign experts to develop meaningful signs for the deaf community. And Audrey has also presented at dozens of science workshops for deaf children all over the UK, and her long-standing commitment to outreach is acknowledged by the fact that she was an educational consultant for the series of 6 science TV programmes for deaf children on the BSL zone, which was called The Secret Lab. And of course, in recognition of Audrey's work, back in 2020, Audrey's work on deaf STEM education and inclusion was acknowledged by the University of Edinburgh in being awarded the prestigious Chancellor's Fellowship. And this meant that she was able to focus her research to address the persistent and widening gap that exists for deaf learners in science. And in 2022, I was very proud to welcome Audrey into the Royal Society of Chemistry as an honorary fellow. And this is the highest honour that the RSC can bestow on an individual. And Audrey, we had a fantastic celebration, I think back in 2023 at our summer party. And I have many wonderful memories of that evening. And then following that, Audrey was recognised with a King's Honour with an OBE for her leadership as the chair of the University British Sign Language Plan Implementation Group, in recognition of contribution to the chemical sciences and Audrey's efforts and inclusion in the science communication. So Audrey, you have had a truly fantastic career to date. I know that you continue to do so much for the community and to really show the leadership, role modelling and also inspiration to others. So I would like to welcome Audrey and hand over to you for your presentation. So thank you.
Is that working for people? Can everybody see that okay? Fabulous. So my research focus is looking at signing, using it to unlock complex scientific concepts, and in particular chemistry concepts. So I've got a half an hour to try and whiz through that with you today. So I wanted to start by just saying that, the deaf chemists have been around for a good amount of time. So just thinking about Gustav Ekberg, who was the person who discovered tantalum in the 18th century, a Swedish person, and also Sir John Cornforth, who got the Nobel Prize for his work around stereochemistry. But I also want to mention another special person who's based here in Edinburgh, a Scottish deaf woman, a chemist, and that's Dr. Christina Cruikshank. Yeah. And who did some incredible work. And there are two buildings in Edinburgh that are named after her. And as I say, she was a deaf woman, a deaf scientist, chemist. And she had a degree, did a 3-year degree at Edinburgh University, but also did a 4-year degree at the same time, a diploma at Heriot-Watt. So she was studying on 2 courses at the same time, quite incredibly. And then she did her PhD and became a lecturer, and then taught many of the students of chemistry at Edinburgh University. And I'm really proud to know that Edinburgh was able to recognize her and her work as a chemist. As a deaf chemist. And there is a picture of her in the chemistry department that celebrates her work, which you can see on my slide just here. The other thing I wanted to say, we're talking about education of deaf children, and I wanted to just say how many deaf children there are globally. And there are 34 million deaf children. That's the figure that the NDCS have come out. Hopefully I've got the figure right, Asma, for America, something like about 10.2 million. And here in the UK, we have 54,321 deaf children. So it's not really a small number. There are indeed a lot of us, and there are lots of deaf children out there. Just focusing on the UK, I'm talking about where they live, looking at the relative populations of the home countries. And England, understandably, has the largest number. 86% of deaf children live in England. But these children have a various experience of deafness. Some of them may have a unilateral hearing loss, or they may be profoundly deaf, or have a mild hearing loss, or they might be born deaf. So their experience of deafness varies. So if we look at that figure, probably 3/4 will need some kind of additional input to access communication. And it might well be that some of those students in the classroom will struggle, for example, if they're sat at the back. So they will need some kind of input, despite their experience or how much they're able to hear in the classroom. Most of them are in mainstream schools, and they will be either in 1s or 2s in those schools. And there are less numbers that go to specialist schools for deaf children, and there'll be some who are in mainstream schools where there is a base, or they might be in specialist schools. But most of those children, those deaf children, will be in mainstream. And my concern would be how much access that they might have and how much opportunity they have to get interested in the subject. And I know Derek's going to talk about his experience of working in the classroom with deaf children a little bit later on. I mean, we know that there's a lot of deaf children here, 54,000, as I mentioned. And what is hugely disappointed is that a piece of research that was commissioned by the Royal Society was looking at how many of those students then go on, in this instance, disabled students, to study STEM at university. And they looked at a period 2007, 2008, and then 2018, 2017. And if you look at the numbers of disabled students, that's actually risen over that 10-year period. So there's been a goodly increase, a positive increase in the number of disabled students going into higher education. But if you look at the numbers of deaf students, that's remained at 0.03% over the same period of time. And you have to wonder, you know, where are we losing these students in what we might think of as a leaky pipeline? We have better access to interpreters for those students, so there's more availability there. So we have to wonder whether the challenges are about them understanding or accessing science using sign language. So signing has been around for many, many, many years, and it's thankfully been legally recognized now as one of the main languages in the UK. And that's true in different parts of the world where signed languages are legally being recognized. And we have the BSL Act here and the Scotland Act 2015 and the UK Act, which was 2022, which legally recognized the sign languages. What's interesting is that prior to that, in 2004, the SQA exam qualifications body made it possible for deaf students to undertake or participate in the exam system using sign language. So they would have teachers who would translate and sign the questions to them, and they would sign their responses, and these would be filmed. And this was in large part to do with Dr. Mary Brennan, who was based here at the University of Edinburgh for many, many years. And back in 1975, she was saying how important it was that deaf children had access to signing, to be able to talk about and learn about their subject. Now, that project was really, really successful, but there were problems around STEM subjects in exams, even though they were being signed, because there was so much terminology that we didn't have signs for. So, for example, we didn't have any maths. There was no standardized way of signing maths terms in BSL. So which is great. Now we have teachers like Derek who are using sign language in the classroom, but most teachers, unfortunately, aren't fluent signers, and especially not those who are working in the sciences or in chemistry. So back in 2004, Jerry Hughes, who was the first deaf teacher in Scotland, I think 1995, he qualified, because at that point, deaf people were then allowed to be able to be teachers. Prior to that, the medical ruling was that you couldn't be a teacher if you couldn't hear a child at the back of the classroom. So that was the ruling. So if you couldn't do that, you wouldn't be able to qualify as a teacher. But Jerry managed to change that ruling, and he became, as I said, the first deaf teacher in Scotland. And what they did was they did a pilot where they introduced some signs, which was very successful. And I'll show you one of the videos that we have on the website, which is one of those early signs. There's a little bit of humor behind this sign as well, if you look at Jerry's facial expression. Okay, so he's talking about non-determinating decimals. And there's a little bit of humor there, mentioning the number of zeros that would then continue after that. As Helen mentioned earlier on, the work of the Scottish Sensory Centre, which is based here at the University of Edinburgh. The centre runs CPD with teachers working with deaf children and with visually impaired children. But we also have a website, the glossary website, which was established in 2007, which now covers 10 topics and includes 4,000 signs. That's where we're up to just now. And they are there to support teachers and to support interpreters and to support deaf children to have access to science subjects. And it means that for those many deaf children that are in mainstream, they can have access to this kind of online resource and give them access. Out of respect and honor for the people that have given us funding along the way, we've had the RSC there. You can see the logo. They funded some of these things. So I'm just going to give you a brief idea of what the website looks like. We have kind of topic areas that are covered on one side, and then we have an A to Z listing of the signs and the terms that we have signs for on the right-hand side there.
Thank you.
And for each of those terms, we have a sign which we've created, but also a definition, which is delivered also in sign. Because what we recognize is that having the sign is not enough if you've never seen that term before. So what we've tried to produce is a bilingual resource, which has a signed definition, and also an English translation of the signing. When we started back in 2007, we recognized that it was kind of really important to give real life examples of the signs so that it would give people an idea of the context. So we went about filming some practicals and some experiments in the lab, and you can see a still from one of those on the PowerPoint there. We've done some evaluation, and the feedback we got was that the students and the people that were using the signs really like the lab demos because it really helped them understand the concept. So this is a younger version of me, a much younger version of me in the lab way back there in 2007. I'm looking very serious, aren't I? I've got these chemicals like I intend to do something, but I'm looking to do something magical with it. I'm just signing here. What a beautiful yellow that is. And I started to use signs like chemical reaction and product and reactants. I want to talk now about the process of developing these signs, how we went about doing that. We have what we hope is a sustainable sign development process. The most important part of which is we wanted it to be deaf-led. Historically, some of these projects have been led by teachers or by interpreters or who have kind of made decisions about what signs should look like. Or even deaf students who've maybe met an interpreter in the classroom and have worked out a sign, but that sign has never then gone beyond that classroom. So there wasn't really a glossary that people could refer to. So now we have a free resource which acts as a kind of glossary, but it's not compulsory in terms of its usage. It's there and it's available for people to use if they choose to use it. But as I say, it's deaf-led and it's deaf-managed. The team is a group of deaf teachers who work with deaf children, sign linguists, and scientists, and they're all fluent signers who are specialists in their respective subject areas. We do still work with non-deaf people if we need to, and that's part of the development process. But the discussion and the conversations about developing signs is amongst deaf people. And you should be able to see Derek somewhere in the photograph there of the core team of participants. As I say, all deaf, all have a degree, all PhDs, all committed to improving access to education for deaf children. Because we've all faced barriers at some point in our lives, and we don't want that to continue for the next generation. We now have a team that we've been building over time, and Derek was involved in the very first glossary conversations back in 2007 when we were talking about chemistry, and also in part in biology, and I think in some of the physics discussions as well. Maybe not, maybe just chemistry and biology I'm seeing from it. So what we actually do is we come together and we have a conversation about the term that we're looking at, what it actually means. We need to be really, really clear about that. Need to be really clear in our minds, because you can't really hide behind a sign. The sign has to be clearly representing the term. And often these can be quite long and drawn conversations and discussions. During COVID, we reverted to being on Zoom, which actually worked quite well for us. So here's a screenshot of us in a similar conversation, but online. And again, lots of toing and froing about the meaning of the word and the possible sign. We've been able to record them, and it's really interesting because we can then look and think of and look at how the signs have kind of developed. You know, who's the creative one in the group? How does the sign emerge? So that's been an interesting process for us to look at as well. So there have been advantages for us moving to the online. And it does mean that we can come together from anywhere in the UK. I know, Michael, you joined us for one of those sessions. I'm right in thinking, am I? Yeah. So the RCS Royal Society of Chemistry have done some research with individuals talking about this idea of belonging. And they had a conversation with deaf people about that sense. But what this glossary project enables us to do is to come together and talk about our passion for the subject. As Helen mentioned, I had no access to interpreters when I was studying, and I wasn't really able to have a conversation with my peers about chemistry. I would maybe have to write notes or read. So to be part of the glossary group has been an incredible opportunity to feel that sense of belonging, which the report from the Royal Society of Chemistry is trying to promote. So I'm going to show you some samples of how these signs have been developed through our process of conversation, and how we've come up with what we would call productive lexicon, which is our process of developing new signs. When we're creating signs, we're trying to create signs that will scaffold an understanding of the concept that these terms lie within. So we're trying to make sure that they're visual, that they're a visual representation of the thing that they represent. And in that way, that helps unpack some of these complex concepts and gives meaning to them. So the signs themselves are really a product of our understanding as members of the glossary group of the actual terms. One of the rules that we kind of follow is that we can't create a sign that incorporates absolutely every element of something. So if I give the example of a rabbit, we don't sign rabbit, kind of hops up and down, slightly plump, fluffy tail. We pick one aspect of the rabbit, which in this case is the ears, and that is the signifier for the sign. So part of our discussions is working out what aspect or part of a term, in terms of what it means, we're going to focus on that will help us to create the sign. So, and I'll show you some examples of this as we go a little bit on later on. The signs we refer to them as being iconic because they typically look like the thing that they try and represent. So just for a moment, if you think yourselves about what a sign for tornado might be, I'm seeing some examples of this like swirling hand shape or finger. Yeah, Esme, what about yours? Yeah, tornado? Okay, lovely. And all of those signs that you've come up with are representative of the thing itself, i.e. a tornado. So let's look at Gary's sign, or the sign that we came up with. I don't know, I tried struggling to be able to play this one because the subtitle's getting in the way. Oh, there we go. There we go. There's Gary with the sign that we came up with. So he's using his left hand as the base for the earth, because if we think about hurricanes, they typically form over the sea. But in this instance, the tornado and the use of the left hand in that kind of horizontal plane shows that they form on the land. Other examples of signs exploit metaphor. So if we think about trying to create a sign for carbon footprint,
Okay.
we try not to follow the English because a literal translation would be a footprint and some representation of carbon. So what we've done is we came up with this sign. Okay. And the sign shows how much carbon is being released into the atmosphere. And you can modify it in that way to show how much or how little. So the sign has that adaptability in it. And you can show the idea of trying to reduce carbon. And in a way, if we think about the term carbon footprint and you compare it with the sign gives much more information and much more clarity visually in terms of the concept. Another mechanism that we use within sign language is what we call compounding, where we're bringing signs together. And you might have seen this before because these are my absolute favorite signs. So what we're doing here is we're using compound signs which are also iconic, and we're using the signs for mass and weight. And people often find those quite difficult to understand, but weight is a force. It is a force that acts on mass. So let me just show you the separate signs and how we've compounded them. So we have mass, Jerry's signing mass there because everything has mass, which is this closed fist. And then we have a sign for gravity, which Gary is going to show you. Gravity, which is that pulling down motion, that force. And if we put them both together, we end up with a sign for weight, which is your mass with the gravity sign compounded to produce a sign for weight. And you can also show the gravitational force by how you present the sign. So if you do it more forcefully, it suggests more gravitational pull. If you do it more slowly, the gravitational pull is less. So it has that capacity to be able to show that kind of detail. And the sign itself shows that weight is a force. The other thing that we use with signs is that we can modify them to show different elements. We can show different types of meaning by modifying them slightly. I'll show you this video first so you get a chance to look at them. They're all signs that relate to the idea of a chemical change. Okay, so this is the core sign is the sign that Audrey's showing you just now. And these signs all follow the pattern of a written equation, which would go from left to right as you write it. The sign follows that same direction. But there are slight variations in these signs, which maybe you will notice if I show you the video.
Okay.
If it's working, which hopefully it is, there we go. So we're using what we call the same base or root sign in each of these instances, which is around this idea of a reaction or chemical change. You can show how fast, which then suggests the degree of the activation energy. So if the activation energy is high, it can be shown in the way the sign is presented. So there's some flexibility there in terms of showing quite detailed meaning. I know that this sign for atom, this is a model. It's not realistic in that sense. But if we're teaching the idea of atomic structure, we've come up with these kind of signs. And the nucleus is always moving, which is why you see this core handshake move. And this right hand finger is in this horizontal plane as a negative charge. So the sign shows the charge of the proton and the electron. I think Michael you were at this session where we were talking about redox reactions, yeah? So redox is is obviously about losing and gaining electrons. And we tried to come up with something that was around this chemical change sign. So it kind of the signs show where the electrons move. I had an interesting discussion actually with some of my PGDE students here at the university who was kind of saying that maybe we need to modify the sign because the two electrons don't just disappear, they go somewhere else. So maybe the sign needs to be changed to make that a little bit clearer. Which yeah, that's interesting. One of the rules that we have in the glossary group is we don't use finger spelling, but there are instances where we are using it. So if we use it in equations, or if we want to use subscript or superscript, or we want to show volume or measurements. And we can show the subscript by, so for example, with O2 here, you can sign the 2 lower down, which shows its subscript. So it's not signed in the same plane, it's lowered. And the same with superscript. You can show it above as opposed to low. Yeah. So it would be cm3 or cubic centimeters instance. And the same with the elements. So AC, for example. So there would be capital A, small c, matches perfectly because it's obviously it's my initial. HG, CL with the lower case L in this instance. So chemistry is the only subject where we have allowed ourselves to use some finger spelling. So just in conclusion there, chemistry education for deaf students requires adaptation, not simplification. You know, these students can succeed using signs, and you'll see in the next presentation from Asmir, you know, the extraordinary achievements of deaf students. You know, we believe that these signs help unlock conceptual understanding. I think for many of us, many students were really struggling with that understanding prior to developing these signs. Exploiting visuality can really help with learning. It really does provide advantages. So we will continue to work on the glossary and make that a visual resource and make STEM subjects accessible for all students. So thank you very much for your time and for your attention. Oh, I did want to just show you before we finish some deaf children, pupils using these signs, a little TikTok video. Just saying that some of these concepts are really quite difficult to understand, but the signs really help unlock those concepts. So if we think about photosynthesis, for example, this open palm shape is the leaf, represents the leaf. We have the sun, and the sunlight and the energy from the sun enables the plant to create food. I love learning chemistry on science, using science, and I want to learn more. So the young girl was just commenting there. Yes, and I have a list of references for those of you who are interested. Okay. And yes, again, finally, thank you, Michael, Asma, and Derek, and the NCC for the honor of being invited, and for everybody for joining us today and for your attention. Thank you so much. Thank you. Hopefully, I've managed to get this on time.
Thank you, Audrey. Perfect timing and an amazing presentation. I think you really gave the scope of the depth of consideration that you're bringing to this development work in developing sign language. And I saw a lot of nods virtually when you were explaining the sort of signature, the iconic part of particular signs, such as you described for endothermic reactions or redox reactions and so on. We have a few minutes for questions if people would like to add them to the chat, but I would just like to sort of round off Helen's opening comments just to say that I guess part of our reason from the point of view of SURG for introducing you and having you as having a symposium in your honor was really an acknowledgement of the fact that there are 118 honorary fellows of the Royal Society of Chemistry, and while I haven't explored every biographical detail in depth, I'm pretty confident that until this week, you were one of the only, if not the only one, whose expertise is centered on education. So, as a research group focused on education, we really wanted to honor you in that regard. Just to give an indication of the prestige of that group of people this week, I can say for certain that a second person has been added to that group. So John Holman has been announced as an honorary fellow this week. So that kind of gives you a sense of the caliber that Audrey is held in. And she'll be sharing more of her expertise this summer at the Gordon Research Conference in the US, which is, really one of the preeminent chemistry education conferences globally. And that'll be, I really hope, an international platform for her to share her amazing work. There's one question in the chat, Audrey, which is asking around the sense of these chemistry signs and the extent to which they're universal in language. And it might also be interesting to get Asma's perspective on that as well.
Yeah, I suspect Asma is going to talk a little bit about this a bit later on. But in terms of we've had I think there's an interesting conversation about when we go to different countries. We've been having these conversations because I think the world is a smaller place, I guess, now, and you would expect signs to be quite different, but actually, or you would expect them to be the same. But I don't know what you think, Asma or Derek.
Yeah, I agree.
Yeah, and Derek saying it's quite difficult, isn't it? If you could repeat that, Derek, because some of the signs are developed, because they are developed using British Sign Language, then they adhere to those rules, so they may not be universal. There will probably be overlap in terms of the signs that different sign languages have created for that concept, but there will be some variation as well because of the rules of that particular sign language.
Yeah.
Yes, I mean certainly different countries have different signed languages, and I wonder whether the science will express itself differently in those languages.
Yeah, I mean that kind of gets to what my question was going to be, which is, as a chemist, when you were sharing some of the signs, as someone who doesn't know sign language, I could understand, why the sign was what you were showing. But obviously, for a student or a learner using sign language, this is one sign in the midst of hundreds of signs in a conversation. And I guess just thinking about the context of understanding, say, the sign for redox versus the sign for exothermic, there was this quite nuanced, to a casual naive eye, there's quite nuanced differences there. And I suppose I was just wondering about the extent of demand, I suppose, on students about using these signs in context.
Yeah, I mean, Derek, you're teaching science every single day. I mean, what do your children make of it?
I think it really depends, Michael, would be the answer. It depends on the topic of the conversation. You wouldn't, discuss with, as hearing people, you probably wouldn't use all these big words and kind of scientific jargon when you're talking to friends that don't share your knowledge of science, do you? So I think it really is dependent on the topic and who you're having that conversation with.
Yeah.
It works exactly the same in sign language. If the person you're talking to in sign language has a similar understanding of the concept, then, you know, because I teach at GCSE level and A level, so we have some very kind of complex conversations around science. So we can use these signs in, you know, the context of those conversations in a way that perhaps they wouldn't be used out with. Maybe a sign for atom might, a more simple complex concept perhaps would be used within more general conversation. But when you're talking about redox reactions and things like that, when you get into that level, then it would mean nothing to somebody who doesn't have the knowledge behind. In the same way, if you just wrote the word in English for somebody, a hearing person, without that background knowledge, they wouldn't kind of get understand English either.
I wonder whether, do you think people they understand it better than they would the English?
Yeah, I suppose actually it's much more visual, isn't it? The sign. So it perhaps unlocks the concepts much more than, say, an English word would. So yeah, I think the sign does help. Kind of, you know, taking the example I gave earlier of atom, the word atom, ATOM, doesn't really give you any additional information at all, does it? Whereas the sign actually adds information, like Audrey's example of carbon footprint. You know, perhaps there's less misunderstanding from people using the signs than there can be in English, because carbon footprint, potentially you don't unlock the meaning of that from the words carbon and the word footprint, do you? In a way that is unlocked through the sign, the visual nature of the sign.
Yeah, fascinating. Thank you. Okay, we better move on for time. There are some questions in the chat, Audrey, that I'll let you deal with, including a prompt as to whether you want to get involved in the wacky world of UPAC. So I'll let you think about that one. But please, can you all join me virtually and otherwise in thanking Audrey very much for that outstanding symposium presentation. Thank you, Audrey.
Well, thank you very much, Michael. Appreciate it.